Once there lived a little farmer girl named Anne who loved her little fish named Libbie. Every day, they would visit each other up the stream, retelling tales of their day. But one day, things changed. The water surface turned odd, green. She couldn't find her beloved anywhere.
Libbie! Libbie!
She screamed far and wide until finally she found him, floating. Picking up his limp body, she rushed to her parents, wondering what could have caused this. It was then that she knew of a new horror, eutrophication.
Let me tell you, dear,
The mother replied.
of a past we thought long gone. Back in the day, the environment was enriched with nutrients, something we thought was good. We used fertilizers for our crops. We wanted a prosperous harvest. Who wouldn't? And at first, it was working. We had healthy crops, bountiful yields, and living our best lives. But one day, after a heavy storm, we went out to see the waters. They were green, filled with algae. The runoff, heavy in phosphate and nitrate fertilizer, resulted in the enrichment of the river, culminating the plant growth. Most importantly, algae. This is called eutrophication, a word that's haunted us for a while. The phosphate and nitrate increases the nutrients in the water, promoting algae growth. In turn, the algae upon the surface blocks the sunlight and lowers the level of oxygen for aquatic life. You might have seen with your dear Libbie, but it's incredibly detrimental towards the water's ecosystem.
As the water bloomed greener, our family grew sicker. You see, as the intensity of the eutrophication spread throughout our available water bodies, there came an emergence in diseases through host-pathogen interaction. Since the river was our sole source of water, we had no choice but to drink. One bacteria that manifested in our water's flora turned nitrate into nitrite when mixed with saliva, which is not only carcinogenic when consumed by humans, but could result in health reductions for infants. Unfortunately, dear, what you saw happen to your dear Libbie was what we nearly saw when you were born. Since your mother drank these infested waters, you were born with several complications, such as lethargy and baby blue syndrome. Had we not treated you immediately, you would have gone, just like Libbie. Ever since then, we took great efforts to stop this phenomenon, but I'm sorry we let it happen again.
How can we stop it?
Cried the little girl.
Listen well. First, we could diversify excess nutrients via conservation drainage practices. This prevents any excess nutrients from culminating to an algae bloom. Second, we need to consistently alter nutrient ratios, as algae is mainly produced by nitrate and phosphate. The altercation will prevent it from happening in the first place. Third, we need to add plant buffers to prevent nutrients from directly reaching these water bodies. Fourth, we need to manage livestock access to streams. The livestock eat plants that include nitrate and phosphate, so when they drink, they also spread those nutrients around. Lastly, we need to promote responsible application of potent algaecides and herbicides. This comes in hand with this nutrient supplies, which prevents any algae bloom directly.
And so, with these precautions, we can prevent eutrophication and the loss of future Libbies in our lives. And so they did. And they lived happily ever healthier. The end.